Yeah, hey everyone. That's a really interesting discussion, Pamela, and definitely one that we we could talk about, especially this week as we do think about like how do we build our data sets and how do we offload um, some of that labor either on each other or to folks outside of this group. I personally have been using Fiverr recently, which again is sort of a similar. You're not paying someone cents, per transaction, but you are sort of like often paying people that live in the global south definitely less than you would pay someone in North America to do tasks. And I have complicated feelings about it because um, I do find these people are like very, very happy to work on projects. But it does feel like, your ours, like, I get a sense many of them have been lowballed on everything. And I sort of make it a promise to myself that if they set a rate, I just go with it. But it's definitely a bit of a challenge. And if anyone wants to discuss using Fiverr more, I'm happy to talk about it um, because it is an option. If you wanted to like have someone else help you cut out images, like they're a human and they can do that work. And um, I honestly find them to be very, very like efficient. They're very good at what they do. But yeah, there's definitely some. I wouldn't even necessarily say it's like unethical completely, but it's definitely like a thing you want to think about and like decide how you want to approach it.
Yeah. I heard that there's like Fivers for Fivers.
That's true too.
So
Yeah.
like someone would take like a gig and it was really, it was actually really just like a team of people. So then even then the pot was further divided.
Yeah.
Um,
I've worked with a person like that, and while that is very efficient, I did feel very weird about that. I prefer to work with someone who I know is like doing the work themselves. Yeah, but it's a none of this stuff is easy, and I would say none of this stuff is like black and white, like this is good, this is bad. Yeah, but that's like a whole other side of ethics that is definitely worth considering and discussing. So Maylee, I know you had also asked about sort of good data set habits, and that's definitely something we'll cover a little bit more today. Um, and if you feel like you don't get enough of it, let us know, and we can keep working on it. Leah and I know I think Stephen was a part of this, and maybe someone else. Um, I think they're not here today, but we taught a 4-week data sets course in like the summer or fall of last year, um, which was like also not really enough to teach everything about data sets that I work on personally. Those recordings are up, and if you want to like spend the next week like digging into those, there's lots of like other good details in there. Like I think the first class or two, like probably about 50 to 75% of that will be covered in today's class. But there's a lot of other details and things to look at if you're interested in that. Um, were there any other questions or things that came up in the group discussion?
I was curious to know what the name of, Stephen, you brought up the name of a different model that deals with text, I think.
Um, yeah, the DALI, clip to DALI, is the same people who did, same guy who did Big Sleep did that. And it, I put a couple images from it on Slack.
Yeah, so Clip is sort of the new, it's a new model from OpenAI, which are the people that did the GPT-2 and 3 models. I'll see if I have a link to it. And then what people have been able to do is they've taken Clip, which is really a classifier model or like a way to classify data, but it's trained on a really, really massive data set. So it should know more than just like 192 classes or something. So people have sort of taken that and used it as a way to uh, basically iteratively train an image. So an image, like you provide it an image clip, and you provide an image, and you provide a piece of text you want to sort of like gear the image toward. And what Clip can do is it can take the text and it can take the image and determine how close it is to what it thinks the correct representation is. And then it can sort of like give you back basically a score. and then you can take that score and use that to iterate on the image. So Ryan Murdoch, who I think is who Steven's talking about, has been doing a lot of different work, basically with using different generators, so different image generators, to generate images, but then using Clip to sort of look at how to score those things and continue to make new images. So I've just been really busy for the past couple weeks, but I've been meaning to take a lot of his notebooks and bring them into the ML Art Collabs. So if anyone's interested in playing with those, I'll definitely share them when they're up. I think one or two of them is in there now, but he also like has a new one every night. So it's like sort of like I can't keep up with him. I'll try to find his Slack handle and share it with everyone. Or sorry, his Twitter handle and share it with everyone in case you're interested in sort of seeing what he does. 'Cause there's some really interesting work that he's been working on. Yeah, Clip is one of these new models where it's like massively trained on pretty much the entire internet, which has its own ethical issues. But it does, in many ways, know, quote unquote, know more than other classifier models do, which is why people are excited about it.
Yeah. So building up from the answer which you gave, Derek. So what I want to understand is if we have a data set, is it necessary to classify everything?
No, so classification is so I mean for most of the data sets that or most of the things we're going to build in this class, you don't need to classify any of your images. It will be assumed that all of your images are one class. For StyleGAN, you can classify your images if you want to sort of say like, here's a bucket of these types of images, here's a bucket of these types of images. I find that's a little bit more advanced, but if you are interested in that, I'm happy to work with you on it.
Okay.
But classifiers in general are sort of like an interesting category of, you know, again, if as we talked about in the first week of class, there's like in a generative adversarial network, there's both a classifier, which is like a scoring system, but there's also a generator, which is what's generating the images. So a lot of times classifiers are purely just like what is this image and how am I deciding that that's what it is, and then generators are sort of added on top of those models.
Okay. Yeah. So just slightly going in deeper side. So as practical example wise, my data set is just a photograph of a people, and it is just working on the faces. I don't have to classify these are the faces or something else. Is that correct?
Yeah, it's actually about like what do you want to do with it once you're done training the model. So let's say this is the worst example, and I wouldn't recommend doing this, but let's say you wanted to classify by skin color or skin type. You could do that, and then what you could do with the generator is actually say, I want a person with this skin tone. Again, I don't recommend doing that, but that's a good example of how to do it with that group. In general, what I think is probably better is just the way FFHQ works, or the way that that StyleGAN model works, is like it's just a pool of people's faces, and the model learns representations based on that. So it's more or less when you're done with the model, do you want to be more specific and say, I want an image from this class to regenerate, or do I want just like any image from within this pool of images? Any other questions? All right, let's move on to starting talking about data sets today. All right, so why data sets? So we talked a little bit about this last week, which is that data sets are sort of the heart of many of the models we're going to look at. I also have an opinion that like data sets are, for the most part, the creative part of machine learning art. Because these models are sort of self-learning, the only way that you can sort of influence them is by making a data set to have them learn on. That's not true of every data set, and there's some ways to play with these using what we would call pre-trained models, which is a lot of what we've done over the past couple weeks. But I find that for a lot of artists, like once you have an idea, you have to figure out how to train your own model to work on that data. So it's definitely like a hugely creative part of the creative process when you're doing machine learning art. And the other reason that I like teaching it is it's hands down like the hardest part of machine learning art. As I mentioned, like you get an extra week in this class to like sort of spend some time to build your data set. I also think it's a really powerful learning lesson. You have probably heard in the tech world talking about big data, you know, these massive collections of data sets. Why is Google or Facebook so obsessed with data? And one of the things I find is helpful is like going through and building your own data set helps you understand just how much of a process of labor this is. And or you can start to see where you can cut corners, and you can start to understand why businesses or people cut corners when making data sets. So I find this to be also just like a very instructive sort of critical approach to thinking about data and thinking about data sets. So I don't know everyone's age in here. I'm from a certain age where like I was really into rap music and really into rap music that would utilize sampling. And I actually have found that building data sets is a lot like sampling. So these were the instruments of the, I guess, 90s era in rap music. And a lot of what they did is you had 5 seconds of audio you could sample per instrument, so they had to get really creative with constraints. And that's kind of what this class is too. You have 2 weeks to build an image data set, whereas many people in the data science world spend months or years building up these data sets. So it's kind of a creative function to try to figure things out. And you start to also figure out what are the good sources, right? So, producers of rap music back in the day, like sort of knew what records or what producers or what labels were the best things to look for. And part of what you will find also is like, if I need 1,000 images, I can't just find one single source because that's very hard to find 1,000 images from there. So you might have to be like, I have to start collecting from this website, and this website, or I have to scan this book, and this book, or I have to generate my own art, and I might not be able to do that in like a very like seamless fashion. So a lot of these processes end up, to me, like feel very similar in a way. And I'd be interested to hear after like you've built your own data sets, like if that matches up with your own experience. So one of the reasons why we're moving into like training our own data is that pre-trained models are fairly limited. Often by resolution, a lot of the pre-trained models that exist out there are 128 by 128. There's only a handful of them that are 1024 by 1024, which is the size we'll be generally shooting for, because artists like high resolution things. They're also very limited by what they offer. You will find a lot of face data sets, and we'll talk through some of those. And you'll find a lot of data sets around various classes of photographs. So again, it's like very photograph based, because in some ways data science is a very literal field. People tend to work with real images, quote unquote, which is like a whole other topic to discuss at some point, but they're mostly working with photographs. So if we want to do anything non-photographic, it's going to be very hard to find data sets. And we should talk about, you probably have heard people talk about biased data or biased data sets. And I think that's a huge topic worth talking about that is probably a full class in and of itself. I think Leah's ethics video begins to cover some of that, but it's a lot more than just that. It's really important to point out that all data sets in some way or another are made by humans, right? So even if no human looks at the data they've actually scraped, someone wrote a scraper to do it, and what website they chose to scrape from, what search terms they chose to scrape from, that was a human decision. And as I'm sure we all know, especially this week, many humans are biased in various reasons. And the truth is, a lot of these, as we begin to, when you're asked to find 1,000 images, it can be hard to find 1,000 images that are not very broad and very general, and that often don't take into consideration minorities or class or race. And these are sort of ongoing issues that we have to deal with. You'll find that many of the pre-trained data sets skirt around various legal issues by using photos of celebrities who are very Western, very white, or they use Creative Commons, which can also be a questionable area of getting information from. So, in some ways, the word bias implies a negative, and I think what we will find in this class is like bias doesn't have to be a negative. It can think of it more as like a filtering, but a lot of the data sets you will see today are kind of biased in a bad way, in a power structure kind of way. As I mentioned before, they're all photograph based. They're very often used for purely business purposes. A lot of the face models are around face recognition or building new TikTok filters. I think we talked about this last week or the week before. A lot of the data sets that are being built that are non-face data sets are for self-driving cars. So there's still like, it's hard to imagine how we turn creative uses out of self-driving car data sets, but they exist. And as I mentioned in the previous slide, they are often very limited in terms of resolution, which is a struggle for artists who are trying to print these works or trying to do higher resolution things. Recently, like we actually did get a new data set that was artistic based. It is NVIDIA's Met Faces model. I think it's something like 1,500 images taken from the Met galleries. But again, you can look at how this is biased as well, because the Met is a largely Western institution. So they're taking artwork from, very Western sources. So it's a lot of white people, a lot of rich white people, because those are the paintings that survived. And they're also like very realism based, right? Like the Met has sort of a certain style or like aesthetic that I think they're probably known for in terms of their collections. So even when we get more artistically aligned data sets, we still get some very biased things. One of the things I like about this particular class is like, congrats, you're basically now an ML researcher and a data scientist. Like you're doing work that a lot of other teams do and struggle with, and I think there are people with PhDs who will probably make worse data sets than you would. And I think that's pretty cool that like we are kind of on the cutting edge of this stuff. Like I guarantee you'll make a data set that someone in this class, or like many of you in this class, will make data sets that I've never seen anyone do before, and I've never seen anyone train on that data. And that will lead to a bunch of like questions, concerns, struggles. But it really is like you are essentially doing research now, because you will often ask me a question like, will this data set work? And my answer will be, I have no idea. So this is kind of, in many ways, these are experimental classes, and we're trying to figure out how to make things work better. I also just want to say, like, a lot of data sets just purely are bad. There's a data set from TensorFlow called TensorFlow Flowers, and this photo is included in that data set. So, and the idea that like you would assume that these data sets that are made publicly available, some human has looked at them and like scrubbed them of like strange images. That generally hasn't happened. I think I mentioned in like the art inspiration video that I recorded, a project that Everest Pipkin did, where they looked at all of the data in like a video data set. And it was like very clearly like no one had looked at this data set. No human had actually like gone through and looked at the data set, and there were some garish things in there. And I think this is a really great example of like, I have a dream of one day doing a class that is all about data sets, and like the first project will just be like download a public data set and look at every image in it, because you'll probably be the first human to actually do that project. So yeah, I mean, a lot of these data sets are scrubbed, scraped from the internet, and no human looks at them. They just run them and they just say, okay, this will work. And it's kind of surprising that half the time, or like most of the time, they do work, because they're full of really bad images, but the machine somehow still manages to work around them. But yeah, if you ever like decide to dig into a data set, you'll definitely find that there's lots of weird stuff in there. So let's talk a little bit about like where you might want to start in building a data set. So the first thing you'll often do is you'll just do a Google search. You'll look it up and you'll be like, I want a data set of shoes. And my first recommendation is usually just to type in what you're looking for and then data set. See if someone's already made it. There are a lot of sort of coding challenge sites these days where like they like see who can develop like the best model to like work with a certain data set, where there's a bounty prize, usually by a big business like Zappos will give you a data set of shoes, and they'll be like, make the best shoe recommender for us, that sort of thing. So those data sets sort of exist, and you can probably find them if you do a good enough Google search for them. There are a bunch of well-known data sets. If you're interested in just digging into them, you can take a look at them and sort of see what they look like. Most of them you probably will find unhelpful in your own process, but they do exist. ImageNet is I believe there's 1,000 classes of images. Each of them has about 1,000 images inside of it. That's actually what they used horses to zebras from. There's one class called horses and one class called zebras, and they just pulled the images out of those. I believe they're fairly high res. I want to say 256 by 256 plus maybe. There's a ton of various like face data sets. So there's labeled faces in the wild, Celeb A, FFHQ, and Sci-Far10 is another one of these like big image class data sets. All the face ones are sort of funny in that like I believe both Celeb A and Label Faces in the Wild are pretty much all celebrities or like famous people, and they were all like pulled in like the late 2000s. So one of the funny things about Celeb A is like the most popular, excuse me, the most popular image in that data set are images of George Bush. So like it basically doesn't even know that like Barack Obama existed, or like maybe thank God it didn't know that Donald Trump was president at any point. Um, so it's kind of interesting to think about also like how these data sets can be stamped in time. FFHQ is pulled from Creative Commons images on Flickr. Um, if you ever want to explore some really weird data set, FFHQ has a ton of weird faces in it. Like, and I don't mean that in like a negative, like derogatory way. I mean like people wearing weird hats, people with interesting like glasses and like makeup and other things. It's a very fascinating data set, but it's all pulled from Flickr. There's also a link here of public image data sets. These are all, this was started by Golan Levin, who's a professor at CMU. So if you want to dig around and see what other people have sort of collected as like, here's an image data set that you can go find, you can click on this link. I will say many of the data sets here are low res and or need someone to write a scraper for them, which can be a bit of a challenge. We'll talk about like, I've got some links to videos on making scrapers if you're a coding person and you're interested in trying that out. But yeah, this is a really interesting, fascinating list of things. If you have like no ideas, coming here, you will definitely find ideas. There's like a 60s political pins data set. There's like a bottle caps data set. There's all sorts of interesting data sets. So if you're just looking for ideas, you might want to start here and see if that sparks any ideas for you. So we'll be talking a little bit. I think Leah will maybe discuss a little bit about how Instagram scraper could work or how you build off that. Actually, I think for homework, that's one of the homework assignments is actually to like watch that. So maybe we'll get to that. But scraping is a very common technique, right? So a lot of us can't generate our own images or don't have access to our own data sets. So a common technique is to scrape images off the internet. And there are many tools to do that. And there's many different sites to pull from. Common ones are things like Pinterest, Instagram, Flickr. This link to Google Images doesn't work anymore. I should have updated this note. I'm going to make a note to remind myself for next time to update this. But there is a Bing scraper. So if you want to scrape sort of like these bigger like image search web pages, you can do that using Bing. One of the challenges with these is you will find that like different data sets have different sort of noisiness levels. So you can imagine Instagram, if you ever looked at a hashtag on Instagram, you'll find that lots of like growth hackers or whoever like have added like hashtags that don't deserve to be on the data sets. So like when you download all these images, you're gonna have to do some cleanup work, and we'll talk about that in a minute when we go through some process stuff. But yeah, there's just a ton of like cleanup to this work. So yeah. Oh, okay, great. Thanks, Leah. I'm gonna update this myself. So yeah, I think there's a lot of places to start to find images, and we have a bunch of recordings on how to actually do that. But if you are interested in like, oh, I found this website, how do I scrape it, or that sort of thing, you can always reach out to Leah and I, and we can find that data. We can like help walk you through that process. Excuse me. The Instagram scraper demo is linked to here. I believe we'll also be mentioning it as the homework assignment. I find Instagram scraper to be one of the easier tools to use because there's usually like only a couple lines of command line stuff you need to edit. Whereas tools like Flickr, you need to get an API key. Bing, you need to sort of like understand how the search results are working. So I would recommend that if you are new to this process, definitely start with Instagram scraper just to get comfortable with it. Scrape one or two accounts or a hashtag and just sort of see how it works. Oh, interesting. So I assume you're asking if there are ways to ensure that your Instagram account cannot be scraped. Is that what you're asking?
Yeah, but also in general.
Well, so basically, if your Instagram account is public, you can probably be scraped. Sorry, it's just true. It's true of pretty much any public website. If your content is public, there's pretty much a good chance that it's either has already been scraped by Google or someone else, or it can be scraped. So yeah, your own private. This is also a great experience to like understand that your own privacy is not really as private as you think it would be. And this, I think, Leah covers in her ethics video very, very well, which is like, how would you want to be treated? Think about treating others like that, you know, in the way that you scrape data and utilize your materials. And then, yeah, once you've built a data set, you know, we'll talk about upload. Basically, you'll upload your data set to Google Drive or something. And while Google Drive probably has some privacy things in there, it's like not, you know, nothing is really that safe on the internet, unfortunately. So I think you can talk about, yeah, so Dakota mentioned you can also scrape it if it's private and a friend decides to scrape it. So be careful who you choose to befriend on the internet. It's true of anything really. Yeah, so there's a lot of ethical concerns, and I think this is where Leah and a lot of other people are getting really interested or like discussing the best practices for that. So I think why don't we take a break now, and then we'll come back and Leah can walk us through like some of the steps in getting set up and like how to think about like once you've scraped a data set, how to go about actually processing it or what we would call normalizing it. So why don't we come back at 30 minutes after? So it'll be 8:30 here on the East Coast, but 30 minutes after wherever you are. Cool. All right. See everybody in 13-ish minutes. Leah, I realized I'm going to take these next couple of slides and then I'll hand it off to you. Cool.
Yep, sounds good.
Great. So really quickly, like there are I think everyone has already done this slide. This was basically watching the homework video and getting this stuff set up. If you haven't yet, or if you're struggling with it, let Leah or I know and we can walk you through it. We will also link to the Instagram scraper demo so you can actually walk through and like get that set up. The slides are here. I'm going to skip over this just because we are running a little short on time. But I definitely recommend watching some of the scraping videos if you're interested in like using those tools, because that will sort of walk you through everything in a little bit of an easier fashion and let you pause and follow along. I do really want to quickly talk about, I know that a lot of folks being artists in here are interested in making their own data sets. And that's certainly a thing you should do or should consider. Obviously, it's like a good way to work with your own work. It has less legal issues or ramifications. And I think it's also interesting to find out what a machine thinks about your own work. So there's clearly lots of ways to do this. Lee and I are happy to discuss each one of these on an individual basis, depending on what you're working on. But there's a lot of ways you can scan or photograph a lot of things. A cool technique, and one that we might look at for folks who are using maybe more abstract things or just things that could be tiled, you can split a large image into many sub-images, which is a nice technique. That's like if you have a big map that's really large, you could break it into smaller pieces and the model might still learn what a map looks like and be able to generate different map tiles. And there's probably lots of other ways you could do that. Some of you are coders in here, maybe some of you are generative artists and could make stuff using code. I think that's an interesting process. A thing that I've seen a lot of folks have fun with is just taking a video and splitting it into frames. I've got a demo on how to do that if anyone's interested in that. One thing I'll note here is that you don't really want every single frame from a video. That just tends to lead to like some issues. You kind of want to take like every 10th frame or every 30th frame of a video. It tends to learn a little bit more of the changes that way. Yeah, you can obviously make a handmade image like animation type of thing and also split that into frames. And if you're interested in what my own process looks like, it's basically this. This is what's above the desk is the to scan pile, and what's below the desk is the to cut up and eventually scan pile. I pretty much have been doing this nonstop since the beginning of the pandemic, and I own way more books than I ever thought I would, and I also like gives me something to do, I guess. So it's okay. But this is when you reach a certain level of addiction about building data sets, this is what happens to you. So I'm sorry if I turn some of you into this. Looks like Steven's like pretty much already there. But some of you may end up going down this path, and I'll just apologize now or warn you to turn around before it's too late. But there are lots of really great clip art books. If you're interested in like, I'll say like if you're interested in like if you have an idea for a data set and I can pass you some images, I'm happy to. Yeah. So really quickly, before we jump into like the actual like making of a data set or the processing of a data set, I do want to highlight that like just remember this, like keep this in the back of your mind, that these are the sort of models we're going to go through, and here are the image data set requirements for each of them. In general, the more data you have, the better your model will train. So these are like the sort of threshold, like floor limits, but there's a lot more. If you can generate more images, you definitely should. So just keep this in mind with these numbers here. So what makes a good data set? I think the most important thing is just something that works. So like just getting enough images is like hands down one of the most important things. Quality is like a different concern. I mean, I think I've shown like pre-trained data sets are like surprisingly bad, but they somehow still work. So I think the next step as an artist is like, how do you clean up your data and make it look really nice and like find the best looking images? A lot of people will do something like they'll take a small image and just upres it. That introduces blurriness into your model. Maybe that's good, maybe that's bad. For most artists, that's bad, but you may just want to get started. Like, so I would say like, perfection is the enemy of good, especially right now in the next 2 weeks. So just getting a data set and like getting enough images is really the key to start with. And as you start training your model, you might learn like, oh, okay, I need to get more images, or I need to clean up these images and actually make them like higher quality or whatever it is. And then, lastly, obviously, like I think having your own data sets, having your own photo studio, like, all this stuff is really helpful. That's, the expert level. Like I don't expect anyone to do that in this course. But if you do have something that you're uniquely good at, like it's always interesting to try to bring that into these machine learning models and make that a part of your process. I always highlight that's the Scott Eaton person with this, where they're like a amazing figure drawer and a photographer and a 3D renderer. It's just like, okay, like you're better than the rest of us, we get it, but that is a really great way to highlight how a really great aesthetic or a really great technician can also like be even better with machine learning. Here's just some really quick examples of like, if you were to scrape like a nebula data set, what would you do with these images? I think these are interesting examples because some of them are bad, but some of them are usable, which is kind of interesting. So like in the case of this hand, it's like clearly some weird like hand-drawn thing. I would probably toss that out. In the case of this logo, it's probably another thing I would toss out. In the case of this image, like if I were really low on images, like in my data set, one thing I could do is I could go into Photoshop and either crop this logo out or like remove it using like another tool. Watermarks are like another particular challenge, but I think you would work around them. And if you find an image like this and it's high res, this is kind of like a holy grail because this could be chopped up into a bunch of different images. So if you can find this at like 8K, like that's great because then you can go in and like, this is where you might use Fiverr or like someone else and like have them go in and cut out each image for you. There are some tools like we can look at in the dataset tools library that might help cut these up individually, but these are kind of like, if you can find these at the right resolution, these are actually really helpful pieces of data to work off of. And I mentioned this before, but like it is sort of funny to look at other people's data sets. This is FFHQ. You can start to see why it learns to generate funny hats on people because there are just sort of funny hats in this data set. And you'll see where other people like end up getting jammed into these data set models in the output because there's a lot of people kissing each other in these things. So, it's like you are what you eat. Like that's a similar way to think about it for data sets. What you put into your data set will generally also be what comes out of it. So it's just sort of helpful to think about that going into these projects. Okay, so now I'm going to turn it over to Leah.
Awesome. Yeah, so next we're going to go over the Dataset Tools repo, which is a repository that Derek created to make like dataset curation and cleaning way easier than like going into Photoshop and like cropping everything by hand or doing all of that. So let me go to the slides. The main usage of it is like after installing the repo, you type Python datasettools.py and you put in your input folder, which will be like your big folder with all of your images, and then your output folder, which is where you want them to be stored. So walking you through like basically the whole life cycle of making a data set. This is a data set that Derek actually made of Bone, this very cute cat from Instagram. The general life cycle is first to go and scrape those images from the internet, then toss out images that are too small. Like Derek mentioned, we're generally aiming for about 1024 by 1024 pixels. So anything smaller than that, like you might upres, but then it might end up a little blurry. 3, toss out any duplicates. Like if you are scraping, you might end up with like images that are identical and you want to remove those from your data set so that there's only one. 4, hand curate. This will be, you scrolling through your big folder and like looking and skimming through and removing things that you think shouldn't belong there. Number 5, this is an optional step. If you need to resize images to the right size to 1024 by 1024, if you need to crop things to square, also augmentation. A couple of you asked about this. If you have data sets that are like lower than like the recommended threshold, ways that you can augment it, like mirroring or flipping things. And then, yeah, number 6, like ideally you scroll through your data set and like check through everything before at the end. Yeah, so to get started, like if we check out Bone29's Instagram, we might see like by default, if we just go and run Instagram scraper, Bone29, we have 2,444 items. So we're like, yeah, that's pretty awesome. But after doing that, we see that there are some videos in here which we can't stick directly in the model. So after basically only filtering on images, this is the command to only grab the images from the user's story posts. Then we're down to 2,089 images. So we've lost about 400. And yet, as you can see, like even only filtering on images, we're still at, we still have like some images that are kind of weird. Like this one is a grid and this one, Bone, is like a minor part of the photo. And there's this other person here. Then the next step you might do is you might throw out everything that is smaller than 1024. So there's a sort.py where you can say the minimum size you want is 1024. And so after this step, we've gone from about 2,000 down to 1,130. Things are looking a little bit stark. I think at some point, Instagram had like a minimum size requirement or maybe like upres everything to a standard size. So I think older Instagram images are more likely to be like lower res. But yeah, generally you might lose a lot if you're imposing a minimum 1024 pixel size. Then the next thing to do is to deduplicate. Deduplicating is like removing exact copies. It defaults to exact copies. There is also a way to do relative matching, although if you use this option, it might take longer. But yeah, the default is absolute matching, meaning if these two things are exact pixel by pixel, exactly the same, remove them. So here we've gone from 1,130 to 1,128. So we've lost 2 duplicates in all of that. One thing to note is that, deduplication isn't perfect. You still might have some issues. So these 2 images are actually, they might look like duplicates, but they're actually slightly different. So the absolute default deduping won't pick up on it. The relative deduping might pick up on it. But yeah, there's even after all of this, there's no code to hand curate images. So yeah, it's still worth, like even after this, all of these steps, we still end up with some images that like this thing on the left, Bone is in a corner of the photo and there's a lot of other background going on. Yeah, here Bone is wearing a backpack, up to you whether you want Bone backpack in your data set. But also here on the right, Bone's face is cut off. And like, you know, if this like, if there were only images like this in the model, then maybe the model might miss out on Bone's ears. The next step is, because these models only consume square images for the most part, or the models will be training for the most part will only consume square images. There's also like a script to go ahead and batch crop everything. So that's with this process type, crop to square. The default is to center crop. So here that might perform kind of well. This one performs pretty well, like all of Bone is in the frame. But here, for this image on the right, you know, Bone's face gets cut in half. And we're probably not that interested in generating Bone's neck. So you might decide there's also an option to top crop with this V-align, vertical line top option. So here, you know, this does better because Bone's face is in the crop. Yeah. There are a plethora of dataset options available. There's, yeah, if you go to the repository, it also includes pretty detailed documentation on all of these different options that are available to help you clean your data set. Yeah, and we do have like a data set playlist on YouTube, and that links to a lot of tutorials that are helpful. And this video here, I believe, was homework last week to install Anaconda, Dataset Tools, and Instagram Scraper. This is a dataset walkthrough of the Bone dataset. And this video here is a tutorial from Derek on how to split a video into single frames, like if we're using a video as your dataset. Yeah, and here we have linked all of these tools to scrape, like if you're scraping from Flickr and Instagram. These are tutorials that Derek has recorded to actually walk you through the process. So yeah, would recommend like clicking through these, and yeah, the magic of tutorial videos is you can always pause and like go and do it on your own and rewind.
Just one note here. So Beautiful Soup is a tool that allows you to pretty much scrape any website as long as you can write some HTML code. So I would sort of say, like, if you find the perfect website and you don't know how to get the data out of it, this is like the moment to reach out to Leah and I, and we can try to see if it's a Beautiful Soup type of project. I generally find that like Flickr is actually like a sort of like low-key great source for data. Instagram is good, but it can be really noisy, and as Leah showed in her data set, like you can lose a lot of images depending on what resolution you want to go through. I should also mention for resolution, we generally teach the 1024 by 1024 style GAN model. So that's generally what I'll recommend people try to shoot for, because that's the highest resolution. If for whatever reason you can't do that, you can do like a 512 by 512 model. So, you know, if for whatever reason you can't find really high res data, you can do other options. And then also like, so Pix2Pix and StyleGAN both require square images. Munit and CycleGAN are a little bit more flexible in that they can take rectangles, because what they do is they do a square patch crop type of thing. So just also like one little note there to keep that in mind. And I'll also say, like, in regards to duplicates, again, this is sort of like a perfection is the enemy of good kind of thing. You don't need to worry too much about duplicates, because one or two duplicates in your entire data set is not a problem. But I do find that when you scrape stuff like Bing and sometimes Instagram, you get a lot of duplicates, like the exact same image like 10 or 15 times, and that can have a negative effect on your data set. So think about these like a class on statistics, where like if you've got too many of the exact same thing, that's going to sort of like pull your data in that direction. So, you know, a couple of duplicates here or there is fine, but if you get like a data set of 1,000 images and 100 of them are the exact same image at different crops or resolutions, you will run into issues with that.
Mhm. Yeah, I've also found in the past when I've scraped from multiple sources, like maybe from Instagram and then Flickr and then Google Images, like that also creates a lot of duplicates because it's on different platforms, but people post the same content to different platforms too. Yeah, and Derek has recorded these videos to step by step, like go through the different options within the dataset library, the dataset tools library. So if you have, like if you particularly are interested in advanced cropping or removing duplicates, like these are good videos to go and review.
And I will say, while the dataset tools library is somewhat documented, is not perfectly documented. So if you do run into issues, that is likely not your fault. That is likely my fault. So please, again, drop notes in Slack or DM me. If you get error messages, I'm happy to walk through those with folks. I also like, this is my own tool library. Like I add to it pretty much every week. So there are very likely new tools or new things. So if you're ever like, hey, I've got a data set that is like half color images and half black and white images. How do I filter out those two? I added that feature like a month or two ago, and I just haven't really recorded a video for it yet. So basically what I would say is if you run into an issue and you're like, how would I do this? Please ask in Slack, and either I will already have a solution for it, or I can think up of a solution for it and add it to the library. That's one of my favorite things about this class is like I can learn new issues that people run into and help build tools to like alleviate them.
Mhm. Yeah, and as Derek mentioned earlier on, is that we taught a whole 4-week class on data sets. So yeah, data sets are kind of, you can always go deeper with data sets. And this playlist contains all of the class material from that 4-week class, which covers a little more data sets in depth if you have like specific interests or things you want to dig deeper into data sets with.
One thing I should also add is there's also a really great class that someone, a guy by the name of Parag Mittal, who teaches at UCLA, recently put up on basically exploring data and like images and like finding out how mathematically like images are close to each other or not. I'll link to that. That's a 6-week class, and each video is, I think, 3 hours long. So if you really, really want to dive into that, you can do that. That is definitely extra work. Like honestly, even I don't do half the stuff he does in there. But he works for Rafiq Anadol, who some of you might know. He is basically like the data person for Rafiq. So he definitely knows his stuff. So I'll link to that if you're really interested in like super nerding out. Like there's a lot of tools that he uses. Like he'll compare these images in a common like sort of classifier system and get their scores out, and then he'll group them by that. I've actually built some tools that will do that if anyone really wants to like try to make the perfect data set. Although in reality, I find that there's no such thing as a perfect data set. It's just like learning to try and experiment with things. But I'll add that link to our class notes if anyone's really interested in digging in deep.
Mm-hmm. Yeah, so your assignment for the next 2 weeks, since we don't have class next week, is to start making a data set, and think about a topic or like a specific model you're interested in, like Pix2Pix or CycleGAN or StyleGAN, and then go and find sources for the images. This could be a data set that exists already or something you can scrape, or multiple sources, or maybe like even your own collection of something. And yeah, we are giving you 2 weeks to do this, even though you can spend months on the process. But yeah, we'll still be having our co-working sessions at regular times, at the same times as usual. And yeah, just to give you a lot of heads down time to go assemble your data sets.
Maybe so you asked if if you can explore more than one. You definitely can. So part of this course, so the next couple weeks after we've made data sets is we're going to explore each of these models in depth. We're going to start training them. So we'll go through the steps in training. We'll go through some like pitfalls to avoid that sort of thing. So if you make more than one data set, you definitely can train on more than one of those. I'd sort of like prioritize your list. What's your favorite? What's your next favorite? Like work from there. But yeah, you'll definitely have time to do more of this. And quite honestly, like training data sets is also like a very time consuming process, but it's kind of hands off. Like every morning you'll sort of set it up and let it run. And the next morning you'll set it up and let it run again. So even as we begin to move on to other things in this class, you still have time to train behind the scenes. So definitely like if you get really into this and you're really interested in making data sets, like definitely please continue and make more of those than necessary. But obviously like we don't expect everyone to make a data set for every model. Especially considering everyone has different schedules and that sort of thing. So we're just going to assume that you've got at least one model you're going to work on, and that's sort of where we'll focus or help you through.
Yeah, and so I think that is all we had for today. But with that, we can close out class with some questions.
I have a question. The GAN types that you guys are recommending that we kind of use specifically with our own data sets were the 5 or 6 that we've been talking about. I think they were outlined in some earlier slides, because we've been kind of poking around and I kind of don't want to get involved in something too complicated, I guess. So again, the 5 were the main ones, right? Like
yeah, so style transfer, action prediction. Oh, thank you. Yeah. So these 5 are sort of the ones I would focus on. I will say for many people, I would recommend against doing picks to picks unless you have a really great idea, because it's very time consuming. So picks to picks is that requires sort of the onion skin sort of idea where you've got images and you've got usually either a drawn representation or some sort of segmentation representation. It's very time consuming. So if you have an idea for that, you really want to go on it, I would say start on that like tonight. I know a couple folks are already started theirs last week. So it can definitely be a challenge. The rest of these I would say like are fairly manageable within 2 weeks. StyleGAN being the hardest just because you need a lot of images and they need to be cropped to squares and you might really want to think about that. I definitely recommend that everyone at least try next frame prediction. We'll probably be covering that starting the first week back. So that one's fairly straightforward in that you just need to find a short video. Like you could probably go on YouTube and find a like stock video to use and you'll be able to get to play with it. So that and style transfer are pretty easy. So we'll cover those 2, but again, they should be fairly doable. So what I would say is like the first 2 you should be able to do, and then I would say like pick one of the later 3 and work off those, or like decide to build a data set around those.
And then this is probably like a gross and broad generalization, and I'll have a better sense of this as I dig into, I guess, my specific use case. But is there any other kind of like general approach to thinking of a data set in an abstract sense? The main one I see is like I'm building up kind of like an almanac of a thing, and I'm looking for one thing, and I want it to be as specific and as accurate. I want to remove things where it isn't framed well. I want to remove background information. I just want the one thing framed up 1,000 times. Is there another way to think about that kind of opens up more options?
I think that's a good way of thinking about it. But I think even within that, you've got some flexibility, right? Like you don't have to have them perfectly framed, right? So, and I can share some examples of this from a class that I just wrapped up with some students at ITP. Like someone just took a bunch of dog photos and like threw them together. Like, they weren't perfectly aligned or anything. They were just a bunch of dogs. And like, it led to some really wild and kind of creepy results. But like, I would say part of this is just starting with a data set, beginning to train off of it. And then you might decide like, oh, I need to make changes to do this. So part of the fun or challenge of machine learning is that you're kind of like, you're almost learning blind. Like you are making something and then you see what it spits back at you and you're trying to figure out the things you need to change how it works, right? It is really like teaching. Like I will say, like the class that I first started teaching this almost 2 years ago, this class is very different than that class, right? Because I've learned like, oh, this works, this doesn't. And that's really what this is you are sort of trying to find the right data set for the right model to do what you need it to do, but you're kind of like not sure what it knows and it's not sure what you know. And you're kind of just trying to negotiate this, which is really challenging. But yeah, I would sort of say like, start with I think where you described it, which is like one almanac or one collection of a type of image, and then see how that works. And then you might make tweaks of like, okay, let's remove all these and keep all these, or find more images of this, and let's add that in and see what we get back. Yeah, so it's like the challenge is kind of like negotiating the data set to do what you want it to do. One last thing before we wrap up for the day. Leah and I are teaching like a 3-hour workshop on April 3rd that is actually about like sort of the guts of dataset tools. So if you're a coder and you're interested in like how that library works, we'll be teaching a class on that. I'll link to it in the notes if anyone's interested. It's sort of an additional cost outside of this class because this is the non-coding class. But if you want to learn how to use OpenCV, which is the tool that I use for the Dataset Tools library, I'll be teaching a class on that. And it's from like noon Eastern time to like 3:30, so it should work for most people's schedules. But yeah, again, there's like no requirement to take that, but if you are interested in more of the coding and behind the scenes stuff, I'll link to that for anyone interested. Any other questions? Oh yeah, so that one will be recorded. So yeah, we record all of our classes and they just definitely go up later. So yeah.
I have a question on using your dataset tools. I have an older version that's working great. Do I need to upgrade it if I want to use the newer tools then?
I probably would. If you use Git to clone it, you can just use Git pull and that'll update it to the latest. There shouldn't be anything that breaks older. Like if you've got a certain command you like, it should all be forward compatible or backward compatible. So there shouldn't be any issues there.
Okay.
They're just new tools essentially. Cool. Well, I look forward to talking to everybody in co-working sessions. Hopefully you've got ideas and you're just trying to figure out how to make them work. And that's what Lee and I are here for. So if you have a data set and you're like, how do I scrape this? Or where do I get these information from? Definitely drop notes in Slack, because my guess is also like Leah and I are probably not the only people that know where cool websites are. So please drop notes in Slack if you're like, I'm looking for this type of thing. Does anyone know other websites that have it? Because I'm sure lots of people here have ideas of where to find things. All right. Well, we will see everyone in 2 weeks, if not in co-working sessions before that.